Question 3, probability. My first question here is my gift to you, and we have 4 options in an event of 1, 2, 3, 4 to be taken out of the sample space 1, 2, 3, 4, 5, 6, 7, 8, 9. Quite simply 4 options out of a total of 9, so the probability is 4 ninths. Part B, we've got a car travelling through sets of traffic lights. So on the first set of traffic lights it's either green or red or orange. Second set, again green or red or orange. And again green, red or orange. Now the probability it would be green is 3 chances out of 5. So 2 chances out of 5 it'll be either red or orange. And completing the diagram, the same options will occur. 3/5, 2/5. Part 2 then asks us what the probability will be that both sets are green. So probability of green is going to be 3/5 times 3/5, which is 9 out of 25. Part 3, or the last part of that, says at least one of the lights will be green. Well, all of these options here have at least one green, so all we're going to do is look at the probability of at least one green is going to be 1, take away the probability that they're both red. So that will be 1 minus 2/5 times 2/5, which is 1 minus 4 25, which is 21 out of 25. Nice and simple. The next one, or part C, we've got Max and Jack throwing dice, and we need to draw a sample space to represent the information. So I'll draw up a nice little box, and this is best shown in a table rather than a tree diagram, and I'll put Max across 1, 2, 3, 4, 5, 6, and Jack coming down 1, 2, 3, 4, 5, 6. And because you are asked to draw a diagram, you will need to complete the entire sample space. But how you complete it is up to you. And because one of the questions asks for the product, I'll just do the product of all of the numbers in here. So multiplying 2, 4, 6, 8, 10, 12, 3, 6, 9, 12, 18, and 3, 6, 9, 15, 18. Gosh, even your teacher gets it wrong. This will be 4, 8, 12, 16, 20, 24, 5, 10, 15, 20, 25, 30, 6, 12, 18, 24, 30, and 36. Now answering the questions. So part 2 asks us if they don't throw the same number. Well, it's easy to actually count up if they do. So all of these numbers, all of these spaces represent the fact that they threw the same number. So a probability of not same, that's going to equal 1 minus the probability that they were the same, which is 1 minus 6 out of 36. That's 1/6, so the answer will be 5/6. Part 2, the numbers thrown by Max is greater than the number thrown by Jack. Well, anything to the right of that line I've just drawn means that Max has thrown a higher number than Jack. So that will represent all of these numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So probability that Max is greater than Jack is 15 out of 36. And the last one, we're asked to see if the product of their numbers is even. And looking closely at the table, most of those numbers are even. It might be easy to count the odd ones. Odd, odd, odd. All of those are even. Odd, odd, odd. Again, even, odd, odd, odd. So 3 rows of 3. Probability of even equals 1 minus the probability of odd. So that was 1 minus 9 out of 36, which gives a solution of 27 out of 36. The next one, an integer is chosen from random from the first 30 positive integers. What is the probability that the number is divisible by 4 or 5? I'm actually going to draw up a nice little Venn diagram, nice cute picture. All of those will represent the multiples of 4 and the multiples of 5. Multiples of 4 would be 4, 8, 12, 16, and I'm going to place 20 in here because it's also a multiple of 5, 24 and 28. Doing the multiples of 5, 5, 10, 15, 20, 25, 30. We would like the probability of 4 or 5 as a multiple or divisible by 4 or 5. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And there were 30 numbers. 12 out of 30, 6 out of 15. Divide that by 3, so that's 2 out of 5. 2 out of every 5 numbers are multiples of 4 or 5. But the probability that the number we choose is divisible by 4 and 5, well, there's only one of those, so that's 1 out of 30. Last question in this section is we've got 2 groups of students, boys and girls. In the first group, there are 7 boys and 3 girls. So 7 out of 10 students are boys and 3 out of 10 are girls. Second group, again, boys and girls. But from this group, there are 6 girls and 4 boys. So 4 out of 10, 6 out of 10, 4 out of 10, 6 out of 10. We've answered the first question, which was to draw a diagram, and the second part says what probability both are chosen from the same sex. Well, that would either be both boys or both girls. So probability of same sex equals probability of boy boy plus the probability of girl girl. So that would be 7 tenths times 4 tenths plus 3 tenths times 6 tenths. Both denominators are 100, so I'll put them all over the 1. 7 fours are 28. 3 sixes are 18. That's 46 out of a total of 100, which simplifies down to 23 out of 50. Last question for probability states, what is the probability that 1 boy and 1 girl are chosen? Well, that's the direct opposite of what we just did. So probability of 1 boy, 1 girl is equal to 1 minus the probability of same sex. So that will be 1 minus 23 out of 50, which is 27 out of 50. I'm assuming you got all of those right. Pretty easy.